Okay, let's talk about interface structure design. Interface structure designs are part of the textbook's coverage of user interfaces. This is not necessarily the only way that you can solve this problem, and I'm not really sure it's even the most common way to solve this problem, but it is actually, I think, fairly simple, and it doesn't get all that complicated. So if you are trying to solve the question at the high level, what should the interface be, meaning essentially what are all the various places that we can go, how do we get there, and how do we navigate back, this is not a complicated way of doing that. So that's the idea behind an interface structure design, and these are the goals you have for interface structure designs. You want to make sure that the next step in the process is always clear, because typically an information system is supporting some sort of a process. A Word document is created in a fairly procedural way, in the same way that like uploading a YouTube video is a sort of procedural process. Creating a blog post is a bit of a process. Even registering for classes, there's steps involved, and you want the interface to be aware of that and make the next step always very clear. But that said, users are possibly going to want to go back to the previous step or possibly start all over entirely, and you want to avoid restricting the user's movement because there are legitimate reasons why they may want to break the usual process and do something slightly different. Most importantly, though, regardless of what the users, whatever position the user has got into, you want to make sure there are no dead ends, that the user always has an ability to go back to the beginning and start over as if they had just opened the application. Navigation mechanisms can help you here, right? Just general navigation mechanisms, back, forward, that sort of thing, for certainly wizard-oriented type processes, but even just a link to the home page or even a link back to the original the loading screen for the application, something like that can make a big difference. These navigation mechanisms need to be consistent, so put them in the same place with the same layout, with the same typeface and the same graphics and coloring and all that sort of stuff, regardless of which screen you're on in the application. And then make sure that it's very clear to the user what are the consequences of leaving a form or clicking on any of these navigation links. Will something be saved as a draft, or will it just be lost to the, lost to time? So make sure this is not a situation where the user ever has any ambiguity about what happens when I click any of these navigating elements. Now, an interface structure design diagram is a way of representing an interface structure design. The idea behind the diagram is to map out all of the user's interactions with the system on a screen-by-screen basis. It's going to represent all the inputs and outputs essentially just as links. There's no data elements associated with them, but you will still see the order they're appearing in. So this allows you to follow that next step path very, very easily. And it can help you keep track of all the navigation paths available to the user simultaneously. So here is an example interface structure design for a fairly simple order taking application. And we've got two different numbers for each of these elements. The first number, the one at the top, represents the ID for the interface, or the ID for the screen. So the main system screen up here at the top with 0 as the number represents sort of like the loading screen, the screen that you would load into when the application is ready to go. And then the number at the bottom, if there is no number there, but these numbers at the bottom represent the process in the data flow diagram or set of data flow diagrams that is actually covered by that screen. So you can have no process, right? This is sort of like an introductory screen. There may not actually be a process in the DFD associated with it. You can have multiple processes. We've got process 1.0 and 2.0, right? There's maybe multiple ways of creating a new order in this application. And then other processes that are listed somewhere in the application. Note that this is a work in progress, right? And we know this is a work in progress because we have 1.0, 2.0, 3.0, and no 4.0. Then there's a 5, a 6, and a 7, right? So this is a work in progress for an interface structure design. I don't know exactly all the details of this particular example, but the key is that you can tell just by looking at this, what we have here, that this is a in-progress design. Now the links represent the ability to travel from one page to the next. These are non-directional, and that generally means that you can go both ways. So if you happen to be on the new customer screen, you can go back to the main system screen, and you can go also to the new order screen, or vice versa, right? So non-directional links imply that you can go in both directions. If these had arrows, which is not something that you see very commonly, certainly not something the textbook covers, then it means you can only go one direction. Okay, so the new customer screen would go to the new order screen, or the new order screen would go to the new customer screen, but not both directions if they had arrows, but these do not. Okay, so there is an activity associated with this set of lectures on creating an interface structure diagram, and again, this is one of those things that we would typically take some time in class to do, and I would walk around and comment on them. And then the diagram, the DFD, is the typical course registration system diagram that we've been working with as another running example throughout the course. So I would recommend taking some time to try and build an interface structure diagram for this DFD. There are some examples in the textbook if you wanted to take one of the DFDs in the textbook and turn it into an interface structure diagram on your own so that you can verify it. That's not a bad way to go. But I think even for something as complicated as this, you should be able to get a very simple interface structure diagram, not too much more complicated than the one that we see here, with some ease.